Hey folks, this is Mr. Woodward. In this video, I'm going to show you how to deal with problems involving forces that are acting on an object at angles, meaning non-90 degree angles. So we're going to use some trigonometry to try to make sense of this. Taking a look here at the top, a few basic strategies are helpful when solving physics problems involving forces at angles. First, always draw a free body diagram of the object and include the angle of any forces that are not acting at 90 degrees. Second, break all angled forces into their x and y components using trigonometry. And finally, treat the sum of forces in the x direction, which is going to be written like this, separately from the sum of the forces in the y direction. Okay, so here's some new notation. This symbol here is the Greek letter sigma, which in math just means sum. Okay, we're going to add some forces up. Okay. So taking into consideration this new symbol, when we say sum of forces in the x, we're just talking about the net force in the x direction. And sum of forces in the y, we're just talking about the net force in the y direction. It's just easier to use the Greek letter sigma for the notation. Let's try an example of really separating the directions x and y and summing the forces in those different directions. Example 1. Here we go. A 15-kilogram sculpture hangs by two cables from the ceiling and the wall of a gallery at the SF MoMA. The angle between the ceiling and the top cable is 50 degrees. I'm going to go ahead and label that here. If the tension in the top cable is 191.89 newtons, so that's this one, and the tension in the side cable is 123.34 newtons, that's this one, show that the sum of the forces in the x is 0, meaning the net force in the x direction is 0, and the sum of the forces in the y direction is 0. Okay? Well, first, let's draw a free body diagram. Okay, here's the sculpture. We've got this force acting out here, this tension acting this way, and then gravity pulling down. Okay? We're told it's a 15-kilogram sculpture, so taking the mass multiplying by 9.8 gives me 147 Newton weight. Okay? This tension, we'll call this tension, well, I'll call this one tension 1, this one tension 2. Tension 1 is 191.89 newtons, tension 2 is 123.34 newtons, and then I'm going to add my angle. Now, here's the thing. If this angle here is 50 degrees, I can also say that this angle here is 50 degrees because of the geometry. Those are alternate interior angles. So I'm going to label on my picture this angle is 50 degrees. It's just a little bit easier to see since that angle is actually like connected to my sculpture, right? Okay, so let's try this out. We're going to sum the forces in the x direction first. All right. Which forces have x components? In other words, which forces are actually acting horizontally? Well, this one certainly is acting horizontally, right? It's pulling to the right. This one has no horizontal components. It's only acting vertically. But this is the tricky one because it's acting vertically and horizontally at the same time. Okay, so I need to break it up into just its horizontal component. And I'm going to do that like this. If we look at this force, the force of tension in the first cable, well, it's partly going to be upwards and it's partly going to be leftwards, right? So I could call this like the force of tension in cable 1 in the y direction only, and then this would be the force of tension in cable 1 in the x direction only. And that's the part that I really care about, okay? So now when I'm looking at the forces in the horizontal direction, I only have two. I have this one pulling to the right, and I have this one pulling to the left. And that's what I want to use in my statement here. So I'm going to say this. I've got the force of tension 2 pulling to the right, so that's positive. And I'm going to add that to the force of tension 1's x component. But since it's pointing to the left, I'm going to call it a negative value. Okay? And then I'm going to see what I get when I add those. Okay? So here we go. The force of tension in the second cable, I already know that, is 123.34 newtons. It's acting to the right, so it's positive. And then I'm going to add that to the force of tension 1 in the x direction. Well, what is that? The force of tension 1 is 191.89 newtons, but not all of that is acting horizontally. Only a component of it is acting horizontally. Okay? So the horizontal component is going to be related to the cosine of that 50-degree angle. Okay, and I need to make sure that this is a negative value. Okay, why the cosine? So let's zoom in on this angle for a second. We've got the force of tension 1 is the 191.89 newtons. It's acting up and to the left. We've got this component here. We've got this component here, right? This is the y component. This is the x component. This is the angle of 50 degrees. Okay, so I want to imagine that I'm just looking at this triangle here. Okay? The x component is the adjacent side, and then the 191.89 newtons is the hypotenuse side, right? And then here's my angle. So I need to relate adjacent to hypotenuse, and cosine is adjacent over hypotenuse. Okay? So if I want to find this side, I can just multiply both sides by hypotenuse, and I find that my adjacent side is equal to the hypotenuse times cosine. And that's what I have here, right? Hypotenuse times the cosine. All right, if I add these together, I find out that I get 123.34 newtons plus negative 123.34 newtons. And so that equals 0. And that checks out. Let's try summing the forces in the y direction. Let's try a new color. Okay. Summing the forces in the y direction. So now I want to go back and I want to consider only the forces that have vertical components. Okay. So now, certainly, this force has a vertical component, so I am going to include that. This force does not have a vertical component, so I'm going to exclude that. And then this part of the tension in the first cable does have a vertical component, so I'm going to use that. Okay, so I only have two forces acting in the vertical direction. So let's start here. Summing the forces in the y direction means that I have the force of tension in the first cable, y component only, plus the negative force of gravity. Negative because it's pointing downwards. Okay? So the y component of the first cable's tension is the 191.89 newtons times the sine of 50 degrees. Okay? And then I'm going to add that to negative 147 newtons. And when I add those up, I get 191.89 newtons. I'm sorry. Didn't add them up. I get, this actually adds up to 147 newtons plus negative 147 newtons equals 0. So that checks out as well. So both in the x and y direction, the sum of the forces is 0.